All right, so a new week, a new chapter. We're going into chapter 15, where we are going to talk about rationals. Now, kind of some bad news right off the bat. If you guys were not very strong with factoring, well, it didn't go away. We're going to factor immediately upon entering this chapter. Silver lining, you get more of a chance to get good. We'll just throw that. All right. So first things first, what do we mean by a rational expression? In short, a rational expression is polynomial divided by polynomial. Right? A rational number is integer divided by integer. A rational expression is polynomial divided by polynomial. So some examples. 3x minus 6 over x squared minus 4. That's a rational expression. Polynomial divided by polynomial. 3/4. I mean, that's technically a rational expression because 3 is a polynomial, degree 0, and 4 is a polynomial, degree 0. 6r to the 5th plus 2r over 7r cubed. Again, this is a rational, polynomial divided by polynomial. So I might even give you a function, f of x equals, say, x squared plus 6 over x minus 6. Polynomial divided by polynomial. If I just look at the numerator, it's a polynomial of what degree? Second degree, or degree 2. If I look at the denominator, it's a polynomial of degree 1, or first degree polynomial. You guys agree? That's going to be important later. Okay. So what if I asked you to find f of 0? What do you do?
Plug in
0 squared plus 6 over 0 minus 6. 6 over negative 6 is negative 1. Could I ask you to find f of negative 1? Negative 1 squared plus 6 over negative 1 minus 6. Seven over negative 7 is? Negative 1. Coincidence. Can I do f of 2? So that's 2 squared plus 6 over 2 minus 6, right? That would be 10 over negative 4. Uh-oh, negative 5/2. Not always the same answer. Can I do f of 6?
No.
6 squared plus 6 over 6 minus 6. That would be 42 over 0. But 42 over 0 is undefined, right? No division by 0. Division by 0 is undefined. Right? What if I had 0 over 42? That's 0, right? But 42 over 0 is undefined. So functions always come with what? Domains, right? But what did the domain represent? It was the x values. Basically, what x values can you plug in? That's its domain, right? Do you see that we have a domain issue here? Could I plug in 6 to this function? No, it came out undefined, right? So we get the first restriction to our domains. Right? So when you're asked to find a domain, your denominator cannot equal 0. All right? Everything else is fine so far. So wherever your denominator equals 0, we have to cut out of the domain. So let's say that I gave you that same function, f of x equals x squared plus 6 over x minus 6, and I wanted the domain. What do? X minus 6 is the denominator, which cannot be 0. You guys agree? Mm-hmm. And what we have here is a not equation, which you solve just like an equation. So x cannot be 6. But the domain is about what x can be, right? We don't want to be negative people. Right? We want to be positive. What can x be? Everything else? So that would be negative infinity up to 6, but not including, union 6 to infinity. That would be my domain. Are you guys with me on that? As we saw, when I tried to plug in 6, I got undefined. If I plug in anything else, I'll get an answer and I'm good. So negative infinity to 6, union 6 to infinity is the domain. Is that okay? What if I gave you f of x equals x minus 5 over 2x squared plus 5x minus 3? And all I'm asking you for here is the domain. Well, denominators cannot be 0. So 2x squared plus 5x minus 3 cannot be 0. How do we solve this one? Yeah, factoring is the method we just learned last time, right? So it's a trinomial, GCF is 1. It's not a perfect square trinomial, so trial and error, right? 2x and x, and what do you want to do? Three and 1? Well, an outer term of 2x and an inner term of 3x would get me to 5x, right? Except how would 2x and 3x get me to 5x? Both positive? But that doesn't work.
It's not going to give you a negative 3.
Because positive 3 and positive 1 multiply to positive 3. So let's try 1 and 3. With an outer term of 6x and an inner term of x, can I get to 5x? Positive 6x for the outer term, negative 1x for the inner term. That gets me to 5x. And negative 1 times 3 is negative 3. So factoring did not go away, not even on the simplest step for this chapter. Right, so you guys are going to need to be factoring champions. Now what do we do? Yeah, break each part down equal to 0, or in this case, not equal. So 2x minus 1 cannot be 0, and x plus 3 cannot equal 0. If either one of those equals 0, they'll multiply to 0, and 0 is exactly what we don't want. So x cannot be 1/2, and x cannot be negative 3. Do you guys agree? You guys on board?
So what do you do with x minus 5? Just keep it as is? Or like...
Can the numerator be 0? Sure. You can have 0 up top. There's no problems with the numerator, no matter what. Right? With rationals. The only problem is with dividing by 0. So the only problem is the denominator cannot be 0. It's a good question. Right? When we talk about domain, we talk about what x can be, and the only problem so far is the denominator cannot be 0. That's it. Is that okay? No problems with the numerators, not here. Of course, this is what x can't be. If you try to plug in 1/2 or -3, you end up dividing by 0. That's why they're no good. Everything else then is in my domain, right? So how do I list my domain? Start at -infinity.
-3.
We'll go up to -3, but we have to cut that one out. Then where?
1/2. No.
-3 to 1/2. Cut that one out, and then
I knew I was missing something.
1/2 to infinity. So imagine this. We took the entire number line from -infinity to infinity. I cut out -3, and I cut out 1/2. So imagine a string. If you make 2 cuts, how many pieces of string do you get? If you have a piece of string and you cut it in 2 places, you get 3 pieces of string. 3 intervals. Is that okay? Common mistake is to leave out that little piece.
No, it makes sense. I just didn't record it. I couldn't
It's okay.
remember.
Lots of people make that mistake. That's why I covered it. Well, thank you. So g of x equals x squared minus 4 over 4. Domain. Well, the only problem with domain we've had so far is denominator cannot be 0. So in this case, 4 can't be 0. Well, 4 is always 4. Is that ever 0? Then do I have any problems? No problems. So my domain is -infinity to infinity. Right? Just because we have the potential for a problem doesn't mean every rational has a problem. You have to check on a case-by-case basis. So how do you check a rational for its domain? What do? Set the denominator not equal to 0 to figure out where that denominator is going to 0 out. That's it. I don't think that's so bad, right? All right. Next up, simplifying. All right, so we're talking about simplifying rational expressions. So our fundamental principle here is if I have a rational expression PR over QR, right? Then do we have a factor in common?
R.
Yeah, and R divided by R would just be 1. So we're left with P over Q. So if you have any common factors can be canceled out, right? The key word in all that stuff that I just said, factor. So in order to cancel, what must you do? Factor. All right? Easily the biggest screw-ups on this one. Trying to slash and burn indiscriminately. That's not how math works. All right? You must factor to cancel. If it is not factored, you'd better not cancel anything in this way. All right, so of course that means right away all of our factoring rules are still in play. So let's say that I gave you 5x squared minus 6x plus 1 divided by 3x squared plus 4x minus 7. Polynomial divided by polynomial, this is a rational expression, right? And all we're doing right now is simplifying. Well, in order to simplify, we must factor. So our job is to factor everything. So it's like double what we did last chapter. We have 2 polynomials to factor, double the fun.
Yay.
So what do we have up top? Trinomial. GCF? 1. Is it a perfect square trinomial? No. Therefore,
Trial and error.
trial and error. What do you got? 5x and x? 1 and 1? Not a whole lot of choices here.
Right.
How's that going to work? Inner term of negative 1x, outer term of negative 5x. Does that give me negative 6x? Do those 2 negative 1s multiply to a positive 1? And then we factored. Round 2. In the denominator, that is trinomial. Is it a perfect square trinomial? Nope. Therefore, trial and error again. What do you got? 3x and x. We have a slight bit more choice on this one. It could be 1 and 7 or 7 and 1. What do you guys think? You're not losing points now. Throw something out there. It's trial and error, so try it. And if it's an error, try again. So you guys said 7 and 1. So if my inner term is a positive 7x and my outer term is a negative 3x, does that get me to 4x? Positive 7 and negative 1 multiplies to negative 7? Good job. Have we factored completely?
No.
It felt like a trap. We have, right?
They have something common.
Yeah, but that's not the factoring part. We have to do all factoring first, and then we can satisfy our bloodlust, killing things off. X minus 1 divided by x minus 1 is 1. Something divided by itself is 1. Something will go into itself one time. So we can cancel, and we're left with 5x minus 1 over 3x plus 7. Now, this is a shooting star, the more you know, reach for the future type thing. Technically, when you cancel out here, you leave a hole behind, right? Could x equal 1?
No.
Why not? It would make the denominator 0, and we can't divide by 0. So even though this canceled out away, it still leaves a hole there. You don't have to worry about this. It's really just a technicality for now, but eventually, lurking back in the mind, you'll come back to this. College algebra. All right, so for our purposes, this is the answer we're looking for. This is the simplified version. What if we had 3 minus 3x squared over x squared plus x minus 2? Polynomial over polynomial, right? So far we're just simplifying. So what does that mean for us? Factoring, right? Factoring never goes away, ever, 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 ever. Okay. So what do we notice about the numerator?
GCF.
There's a GCF of
3.
3. Should I exercise my option to take out the negative?
Yes.
How do you know? You're right. What's your leading term in the numerator? Isn't it the square term? And that's negative? So optional. we could rewrite the numerator in descending order, which would be negative 3x squared plus 3, right? And I told you, whenever your leading term is negative, that's that red flag that signifies you may want to exercise that option to factor the negative out with the GCF. So if we pull negative 3 out from the numerator, what do we have left? Isn't it x squared minus 1? Is that so? If you redistribute, you get negative 3x squared plus 3, right? But what do you notice about x squared minus 1? Yeah, it's a difference of squares. A squared minus b squared. So we've got a negative 3, and then what? Yeah, I went ahead and put the plus first. I'm more positive than you are. But it doesn't matter as long as they're both there. X plus 1, x minus 1. What about the denominator? Trinomial GCF1, is it a perfect square trinomial? Because of the 2, it's not, and therefore,
X plus 1, X minus 2.
trial and error. X and x, 1 and 2, a minus x for the inner term, a plus 2x for the outer term. Does that give us what we need? Yes. Now again, if you had written x plus 2, x minus 1, that's the same thing. That's okay. All right? Just like in top, if you did x minus 1, then x plus 1, that's okay. Have we fully factored? Then, and only then, can we look to cancel. Do we have any factors in common to divide away? X minus 1 divided by x minus 1 is 1. And 1 doesn't change anything. So I've got negative 3, x plus 1 over x plus 2. Right? Again, we have a technicality of that whole left behind, but that's just for a back of the mind. All right, let me get some neck action out of you guys. All right, were you comfortable with your factoring? All right, were you? I mean, I'm going to grade your test. I'm a no, but warn me now. All right, are we working with good factoring right now, or are we working with like factoring? What's that? Okay. Then we level up. And by level up, I mean go to our next section. 15.2, multiplication and division of rational expressions. Now, you guys should already have been exposed to multiplying fractions. How do you multiply fractions? Straight across. Top times top, bottom times bottom. So if you have P over Q times R over S, that's PR over QS, right? That's how you multiply fractions straight across. Anybody shocked? Okay. Only now our fractions aren't just numbers. Now they're rational expressions. So they can have variables. So, multiplying rational expressions. What's step number 1? Factor. Factor completely. You will never escape. Then you can cancel out. Now they say that you can do 1 and negative 1. Don't worry about that. As long as you factor the way we've been factoring, it's going to be 1. And then whatever's left, multiply straight across. All right? Which is how you know how to multiply fractions. So basically, we're multiplying straight across. We just have to have everything factored up just in case anything simplifies. Not so bad. Let's say that we have x cubed plus 27 over negative 2 minus 6 times 4x cubed over x squared minus 3x plus 9. So I'm multiplying these two rationals together, right? So what do? Factor everything. And that first numerator is sum of cubes. Who's playing the role of A? X. Who's playing the role of B? 3, because that's 3 cubed. So how does that work? You guys tell me. X cubed plus 27 factors into Very good. Looking forward to grading your test and no one else's. Indeed. Remember to use soap. Same, opposite, always positive. So here we have factored our sum of cubes. What about the denominator? GCF is 2, leading term is negative, so let's factor that out. Pulling out a negative 2 leaves me with x plus 3. Our second fraction, 4x cubed, is a monomial, so it just is what it is. Meanwhile, x squared minus 3x plus 9 is actually prime. All right? You might be tempted to think it's a perfect square, right? Because you got a squared and b squared. But what has to be in the middle for a perfect square? 2ab. So is the middle 3x doubled? No, it's just 3x. It's not a perfect square trinomial. And in fact, if you try trial and error, you will find that it's prime. But we have another hint. The quadratic that we got out of the sum of cubes, in general, it doesn't factor any further. And that's the same expression. So you would know, if you have a little bit of forethought, right, you would then know that this isn't going to factor any further. It just is what it is. So have we factored completely? Yeah. So how does multiplication work? So just connect it, make it one big happy fraction.
Can those cancel?
They will now,
Okay.
because x squared minus 3x plus 9 divided by x squared minus 3x plus 9 is 1. What else? X plus 3 divided by x plus 3. What else?
4x cubed.
4 and negative 2 will reduce, won't it? So, this is a bloodbath. What survived the carnage in the numerator? Negative 2x cubed. And the denominator? Just 1. We don't have to write divided by 1, right? You guys agree? Who saw that coming out that nicely? No use to it. What if we had x cubed plus x squared y plus x plus y over 5x cubed plus 5x times 6x squared over 2x squared minus 2y squared. So we're multiplying these two rationals together. All right, so what do? Whispered on the winds. Yes, factor. Right? Factor everything. And this is going to be a lot of fun, because what do we do with that first numerator? That's factoring by grouping. 4 terms, right? So what do the first two have in common? If I pull out an x squared, that would leave me with x plus y. And of course, the second grouping is x plus y. You guys agree? What do those have in common? Two terms here. Do they have something in common?
X plus Y.
If I factor out x plus y, that leaves me with x squared plus 1. Right? X squared from the first term, 1 from the second term. Now, x squared plus 1, for those binomials, right, with two terms, there were three special factoring forms: a difference of squares, a difference of cubes, and a sum of cubes. Is this any of those? Nope. That's it. Is that okay? What about your denominator there?
Take out a 5x.
You got a GCF of 5x leaving behind
X squared plus 1.
x squared plus 1. Does that factor any further? Nope, right? X squared plus 1 is not one of those special forms. All right, 6x squared is 6x squared. Right, that one is what it is. What about 2x squared minus 2y squared? We have a GCF of 2, which would leave behind
X squared plus Y squared.
x squared minus y squared.
Oh,
Now, I mean, you know, I didn't write it in place. I wrote it off to the side, so that's a hint that what?
that's right.
It's going to factor further. Because what do you have? You have a difference of squares. A squared minus b squared. So how does that factor? Yep, so we got the 2, and then we have x plus y, x minus y. Right? You guys are all factoring champions? Right? You're giving me lots of drool, and that drool had better be backed up. Right? Once we fully factor it, how do you multiply? Straight across. Connect the lines, one big happy fraction bar. Do we have common factors that we can cancel? What do we have? Mumble, mumble. X plus y divided by x plus y. That's 1.
X squared plus 1.
We got x squared plus 1 divided by x squared plus 1. That's 1. The 2 would reduce the 6. And then the x will reduce the x squared. So what's left?
3x on the top.
3x over
X minus Y.
5 times x minus y. Is that okay? You guys with me on that? Okay. By far, the most important thing here to remember is when you are going to simplify, you must have factored everything. Factor, 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 factor. If I sound like one of the adults in Charlie Brown, the want-wants should sound like factor. All right? Okay, so that's multiplying. What comes next? Indeed, we shall divide. And you guys know how to divide fractions already. If I have p over q divided by r over s, how do you divide two fractions? You multiply the first one by the reciprocal of the second. So you change division into multiplication, and you flip the second fraction. So P over Q stays as is, then times S over R, and then we already know how to multiply. Straight across, right? Same rule applies even when we're dealing with these rational expressions. So it's really just what we've been doing, plus an extra step at the beginning. So if I have 12y cubed over 5y squared minus 5 divided by 6 over 1 minus y. So I'm dividing two rationals. What do? So 12y cubed over 5y squared minus 5 times 1 minus y over 6. Right? And then what do we do now? Factor. All right? Factor everything. So 12y cubed just is what it is, right? What about the denominator? You have a GCF of 5, right? Leaving behind
Y squared minus 1.
I wrote it off to the side. Why is that? We're not done. Y squared minus 1 is a difference of squares. If you thought you were escaping anything, you're a sucker. So that's 5 times y plus 1, y minus 1. What about the other side? Well, that numerator is not written in descending order. If I write it in descending order, wouldn't it be negative y plus 1? So what does this hint to us? Pull out a negative 1, which would leave behind y minus 1. I'll emphasize that negative 1 we pulled out. And 6 is 6. Nobody's rocked by that revelation. Have I fully factored? Yes. Once we're fully factored, how do we multiply? Straight across. That's the easiest step. Just connect your dots. Right? Connect one big happy fraction. And now that's it for multiplying. You've actually done the multiplying. We just have to simplify. Can we simplify anything? Y minus 1 divided by y minus 1 is 1. 6 will reduce the 12. That's it. So negative 2y cubed over 5 times y plus 1. Negative 2y cubed over 5 times y plus 1. Everybody okay with that?
Because you factor out the negative 1 on that side, right?
Yep. So 2 times negative 1 is going to be a negative 2.
Some people would forget that.
Yeah, that's why I put it there. It's almost like I get paid to plan for this stuff. All right. What if I give you xy minus y squared over x squared plus 2x plus 1 divided by 2x squared plus xy minus 3y squared over 2x squared plus 5xy plus 3y squared. Now, the number one mistake, you cannot just start slash and burn. What do we actually need to do? Dividing two fractions means we'll multiply by the reciprocal. So I have xy minus y squared over x squared plus 2x plus 1 times 2x squared plus 5xy plus 3y squared over 2x squared plus xy minus 3y squared. Right? We deal with division of fractions by doing multiplying by the reciprocal, right? Now what? Say it with confidence.
Factor.
You will factor everything. That is the mistake. You guys should be so ashamed of yourselves if you do not factor on the test. All right? Shame, shame, shame. I'll write shame and give it back to you. All right, so factoring. Factor, 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 factor. I've said it many times. What can I do at the top? There is a GCF of y. Now, a good point is raised here. Should I factor out the negative or not? Is this in descending order with respect to x?
Respect to x.
Yes. The bottom's descending order with respect to x. The other two descending order with respect to x. So if I'm considering everything in descending order with respect to x, is my leading term negative? No. So don't pull out the negative. Now, you could have rewritten everything to be in descending order in terms of y. Then you would have pulled out the negative. It actually winds up in the same place. So those of you with extra time over the weekend, you can do it that way and verify. Just for funsies. Okay, what can we do with the denominator of that first fraction? Well, yes.
Perfect square.
It is a perfect square trinomial, right? We've got x squared and 1 squared, and the middle is 1x doubled, right? So this is a perfect square trinomial, so we get x plus 1 quantity squared. I like it. You said factoring, I'll take it. Count that as a victory. All right, what about the second one? Those are both trinomials, but this time neither one of those are perfect square trinomials. So that means trial and error. Now, just be careful. There's no GCF other than 1, right? They don't all have x's. They don't all have y's. The numbers don't have anything in common besides 1. So there's no GCF. So just good old trial and error where we use 2x and x and 3y and y?
Yes.
So let's check. Inner term would be 3xy. Outer term would be 2xy. That does get me to 5xy, right? As long as
They're both positive.
they're both positive. And positive 3y and positive y multiply to positive 3y squared. So it checks out. You guys agree? Denominator, same basic idea. We have 2x and x. And what do you think? Y and 3y? Let's see. If my outer term is a positive 6xy and my inner term is a negative xy, right, what would that give me? 5xy? That's not what we want. What do we want? 1xy. So try again, right? That's how trial and error works. What do you want to do this time? 3y and y? I heard it whispered on the winds. So how am I going to make this one work? Positive 3xy for the inside, negative 2xy for the outside. Does that give me to xy? Is that okay? All right, and then positive 3y times negative y is negative 3y squared. That's it, just trial and error. If you try a wrong pair, go back and try again. There are only so many options. So just by process of elimination, if you're doing it, you're going to get to the right answer. Right? Okay, did we factor completely? Yes. So how do we multiply two fractions? Connect straight across. Any common factors to cancel? 2x plus 3y over 2x plus 3y is 1. X minus y divided by x minus y is 1. Anything else? Then what do we have left? Y times x plus y over x plus 1 squared. Is that okay? Let's do one more. What if I give you 5x over 2x minus 6 divided by x over x squared plus 7x plus 12. I want you guys to take the reins. You're getting too quiet on me. Tell me what to write next. You tell me what to write. 5x over 2x minus 6 times x squared plus 7x plus 12 over x. You guys agree? Tell me what to write next. 5x stays the same.
Take out a 2. X minus 3.
2 times x minus 3. Everybody on board?
Bottom stays the same.
Yeah. Pluck the low-hanging fruit first. The bottom stays the same over x.
Factor.
Yeah. X and x.
3 and 4.
3 and 4. How's that going to work? You guys agree? Okay. How do I multiply? Straight across. Now what?
Take up the x.
So x divided by x does cancel, right?
And that's it.
If you use the option to minus negative, plus x plus 4 plus 3 at the bottom.
If you pulled out a negative, this would actually flip to a negative x plus 3. It still won't match. Sometimes the hardest thing to do is walk away. Nothing else cancels. Right? By far, you guys are too bloodthirsty for your own good. And you cancel way more than you should. Sometimes this is it. So we got 5 times x plus 3x plus 4 over 2 times x minus 3. That's it. I know you guys just want to start canceling stuff out, but that's just not how life works. Guess what? Next section. So in 15.3, we are going to talk about least common denominators, LCDs. Now, we have a couple of things going on that you guys in isolation can do just fine, but somehow now that we've learned both of these things, you get confused. LCDs and GCFs are not the same. All right? So if we looked at (6) and 15. What is their GCF? That's the part we're probably more fresh on at the moment. 3. The GCF is something smaller that goes into both of them. You guys agree? Mm-hmm. Meanwhile, what is the LCD? Your LCD is 30. The LCD is something larger that both of them go into, right? So don't confuse these concepts. The GCF is something smaller that would go into all of them. The LCD is something bigger that they all go into, all right? Now, you guys have practiced both of these with numbers, and then we've practiced GCFs with variables. We haven't done an LCD with variables, and so that's what's coming up next. So just finding the least common denominator for rational expressions. So finding an LCD. Step 1.
Factor.
It's factoring. Right? Nobody should be shocked. I warned you that this would happen. This day would come. That factoring just rains down like heavenly fire. Okay, so you're going to factor everything completely, and then the LCD is going to be the product of unique prime factors. In other words, anything that you have in your denominators, you need to account for it in the LCD. All right? But least common denominator. You don't want to take extra. Don't get greedy here. All right? Could I have said 60? That would be a common denominator, but it's not a least common denominator. It's taking too much, right? So that's the idea here, is we don't want to take too much. We want the LCD, the least common denominator. So don't get greedy. Just take what you need. So if I gave you, for example, (7 over 20x squared y cubed) 9 over 15xy to the 4th. Right. Now, some of you guys had developed a pretty good intuition for finding LCD with just numbers. All right. Let's see how well it goes for you here. Can you guys tell me the LCD? Is this right?
I was getting
So what has to happen? What is the LCD? It's got to be something bigger that they both can go into. Will 20x squared y cubed go into 60x squared y to the 4th? Yes. Will 15xy to the 4th go into 60x squared y to the 4th? Yes. Now, how confident do you guys all feel? He came up with it pretty quickly. All right. Is he an expert LCDer?
Mm-hmm.
You guys maybe... Officially, the way that you go about this is breaking it down into your prime factors. So 20, for example, would be 4 times 5. So that's 2 squared times 5. X squared y cubed. You guys agree? 15, meanwhile, is 3 times 5 times x times y to the 4th. You guys agree? Use the prime factorization. So what do you take from this? You need a 2 squared. You need a 3. You need a 5, right? Do I need 2 5s or just one? Just one, right? I only have 1 5 here. I only have 1 5 here, so 1 5 is enough. Don't get greedy. Just take what you need. Okay. What about x's? How many do I need? Two of them. What about y's? How many do I need? 4 of them. Right? I have 3 here, 4 here. I have to have enough for them to go into, so how many do I need? 4. Just enough that I can handle both of them. I heard somebody kind of get confused with the GCF out there. I know that's the temptation. Right? LCD has got to be something bigger that they both go into. Right? So it's in a sort of light, an opposite of a GCF. Okay? But if this is what we're taking, what does that give you? 60x squared y to the 4th. Is that okay? Okay, if that baked your ZD, once we identify the LCDs, what we're going to do is we are going to unreduce so that we can write our fractions with the common denominator. So, tell me, what was my first fraction missing?
3y.
It was missing 3y. If I multiplied the bottom by 3y, I have to multiply the top by 3y. You guys agree? Then what would I get? 21y over 60x squared y to the 4th. Do you guys see what I did there? Oop, I wrote it wrong, even if I said it right. All right, so let's do the same thing with our second fraction. What are we missing here?
Where did you get the 3y from?
Very good question. I didn't get it, he got it.
I really don't know how.
So look at what we did. What did we have from that second one?
X squared y cubed.
So we have 2 squared 5 x squared y cubed. What was our LCD consisting of? 2 squared 3
Oh, I see.
5 x squared y to the 4th. What was missing?
I see.
A
Okay.
3 and a y, right?
I
Yes,
see.
that's a good question. I was waiting for it.
I was like, what? What?
He just made it up, right?
Gosh.
So now, what do you think we're going to do for the second one?
You're missing a 4.
Yeah, you're missing the 2 squared, which is a 4, and you're missing an x.
4x.
For posterity's sake, I'm writing it as 2 squared. 4 is totally fine.
Okay.
Because when I multiply it in, what's that going to be? 36x over 60x squared y to the 4th. Is that okay? So now they have a common denominator, don't they? They're both written in terms of the common denominator. That's it for this. We'll do stuff with it momentarily. But for the moment, we're just finding it.
Yeah, we're looking at your little funky kid. They don't ever end there.
What if I give you x plus 4 over x squared minus 36 x over x squared plus 12x plus 36 and then x cubed over 3x squared plus 19x plus 6. So I have three different expressions. Now all I'm doing is I'm going to identify the LCD, and then I'm just going to write them all in terms of the LCD, right? So this is a little more complicated, but it works the same way. I have to see what I have, and that means factoring, right? Before it was monomials, but this is more exciting than that. What can I do with x squared minus 36? X plus 6, x minus 6, it's the difference of squares, right? What about the second denominator? More eloquently put, x plus 6 squared, because it is a perfect square trinomial. A is x, b is 6. Isn't that 6x doubled in the middle? Mm-hmm. It's a perfect square trinomial, so it's x plus 6 quantity squared. You guys agree? And the last one, some good old trial and error. We got 3x and x, and what you want to do? Mumble, mumble. 1 and 6. So if I have a positive 18x for my outer and a positive x for the inner, that's positive 19x. And it multiplies 1 and 6 to a positive 6. Good job. What is our LCD? X plus 6 squared. Why did I need two of those?
There's two.
You actually have two on that middle one. So you have to have at least two. Do I need 4 of them?
No, you only need 2.
Yeah, 2 is enough to deal with each of these. Don't get greedy. What else do I need? I need an x minus 6 and a 3x plus 1. That's what I need. Let me see some neck action out of you guys. Do you see how I got the LCD? Do you see LCD? Middle? Yes? Over here on the side? Some of you guys think that if you avoid eye contact, I'm just not going to figure it out. I will grade your test. Right? That's not the best time for you guys to be like, oh, I don't know what this is. Right? This is a better time for that. So this is my LCD. It takes care of all of these things. Now, let's write these all in terms of the LCD. So tell me, what is my first term missing?
X plus 2 squared, 3x plus 1.
So it's missing a 3x plus 1, and it's missing one of the x plus 6's. You guys agree? So if that's what's missing, I multiply it in, which means multiply it into the numerator as well. So that's x plus 6, 3x plus 1 times x plus 4 over x plus 6 squared, x minus 6, 3x plus 1. Do you see how I identified what was missing and what was needed to get it over the LCD? Is that part okay? For the moment, we're not doing anything more with it. We're just identifying. All right. if we look at the second one, what's missing? An x minus 6 and 3x plus 1. So if I have to multiply those into the denominator, I have to multiply those in to the numerator. So we've got x minus 6, 3x plus 1 over x plus 6 squared, x minus 6, 3x plus 1. Again, do you guys see how I identified what was missing to rewrite it in terms of the common denominator? Last expression. What's missing? An x minus 6 as well as one more x plus 6. Do you guys agree? So if I multiply the bottom, I have to multiply the top by the same thing. X cubed, x minus 6, x plus 6, over x plus 6 squared, x minus 6, 3x plus 1. Are you with me? So we're about to level up.
Dear God, send help.
Right, so we can identify the LCD. It's actually easier, I think, with the expressions than it is with the numbers. I think it's easier to pick it out. Right? They're a little more obvious. Okay, because that was that whole section. So we're moving to the next section, 15.4, where we're going to use it. So addition and subtraction. So multiplication and division was pretty easy. Multiply straight across, division flip, and multiply straight across. Right? Addition and subtraction is where we gum up the works a little bit. So there's good news and there's bad news in this section. Good news first. If you already have a common denominator, p over q plus r over q, the common denominator there is q, then you simply write all of the action in the numerator over the common denominator, p plus r over q. That's it. Same thing with subtraction. P over q minus r over q, common denominator, q. So move the action up, p minus r, all over that common denominator. We're calling it a common denominator, so write it all over the common denominator. Easy peasy, right? When you have a common denominator. So let's say, for example, that I gave you x over 5y cubed minus x plus 2 over 5y cubed. So I'm subtracting rationals, right? Do I have a common denominator? Yeah, 5y cubed. So all the action goes to the top. So we simply write x minus x plus 2. Now, notice that minus applied to the whole second fraction, right? So when I put all that in the numerator, that minus still has to apply to the whole x plus 2. So I use parentheses there. And what does that mean? Distribute. And we get x minus 2 over 5y cubed. Are you guys okay with that? Right? The minus still has to apply to the whole numerator since it applied to the whole second fraction. And what happens? X minus x is 0, so you just have minus 2 over 5y cubed. Is that okay?
Oh, we don't have 5y cubed, but we have something else with it.
We'll talk about that.
Oh.
Yeah. I'm starting you off with the nice case. What if I give you 9 over x plus 3 minus x squared over x plus 3? I'm subtracting rationals, right? Do I have a common denominator? Yes. Then you put everything over the common denominator and all the action goes to the top. So what do we have? 9 minus x squared. You guys agree? Got a little overexcited with my fraction bar there. Now, unlike the previous one, might I simplify? Well, in order to check, what do I have to do? Factor.
X plus 2x minus
3. If I rewrite it in descending order, that's negative x squared plus 9, right? So what would I do? Choose to factor out a negative, leaving you with x squared x squared minus 9. And x squared minus 9 is what?
X plus 3x minus 3.
A difference of squares, x plus 3x minus 3. You guys agree? Now, you could have factored 9 minus x squared directly as 3 plus x, 3 minus x, and that would work. But it's better to stay consistent, write in descending order, factor out a negative if the leading term is negative, and then go from there. Can I cancel?
X plus 3.
X plus 3 divided by x plus 3. So I'm left with a negative x minus 3. You guys agree? Which is fine, but that's also the same as 3 minus x if I distribute the negative back. I don't care which of those final answers you use, just so you know. What if I have x squared minus 5x minus 15 over x squared plus 5x plus 6 plus 2x plus 5 over x squared plus 5x plus 6. Do I have a common denominator?
C.
Yep, one last time. Then I rip that rug out from under you. Your common denominator is x squared plus 5x plus 6, right? So what do? All the action moves to the top. So you have x squared minus 5x minus 15 plus 2x plus 5. You guys agree? What's in front of my parentheses? Just 1, right? And 1 times anything is itself. So I can drop the parentheses since it's just positive 1. And then how do I add polynomials? Combine like terms. So I'm going to get x squared minus 3x minus 10 over x squared plus 5x plus 6. Do you guys see how I did that? Right? And the addition part is done. All we have to check for now is to see if it simplifies, and in order to do that, factor everything. Both of these are trinomials. Neither of them are perfect square trinomials, so our only option is to try trial and error, right? So what do you got? X and x for the top and so if we do x plus 2 and x minus 5, does that give me what I need? All right, what about the bottom? X and x. Two and 3. Plus plus, does that give me what I need? So do we have factors in common? X plus 2 divided by x plus 2 is 1, so we're left with x minus 5 over x plus 3. Is that okay? So all that jazz added together worked out rather nice. All right, this is where the other shoe drops. So, if we do not have an LCD, then we have to find one. And once we find one, we have to unreduce so that everything is in terms of that common denominator. And then, as we did before, move all the action to the numerator, work it out, simplify if we can. All right? So, we're going to have to identify the LCD, which means factoring all the denominators. We're going to rewrite everything over the common denominator so that we can add or subtract, and then we're going to simplify. We'll start with something simple. Seven over 6x squared plus 2 over 9x. I want to add, right? Do I have a common denominator? No. And that means I have to find the LCD. What is my LCD? That's GCF. What is the LCD? 18x squared. Right? The LCD is 18x squared. Can 18x squared take care of 6x squared? Yes. Can 18x squared take care of 9x? Yes, that's the idea. Right? We need something bigger that they can both go into. So if my LCD is 18x squared, now what is the first fraction missing? A 3. So if I multiply the denominator by 3, I have to multiply the numerator by 3 as well. So that's going to be 21, carry down the plus. What is my second fraction missing? 2x. So if I multiply the bottom by 2x, I have to multiply the top by 2x. So that's going to give me 4x. Is that okay? So to see if this simplifies, I would need to factor everything. Well, the denominator is monomial. It is what it is. The top is a binomial, no GCF other than 1. And if it's a binomial, there are only 3 special forms. Is it a difference of squares up top? No. Is it a difference of cubes? No. Is it a sum of cubes? No. Then that's it. This is our answer. Whew. If you want to write it in descending order, that's great, but it's not going to change that you cannot factor it any further. There are no common factors. Nothing cancels. You leave a hungry lion. You're not able to slash and burn. All right, so let's see about 6x over x minus 5 minus 1 over x plus 5. We want to subtract. Do I have a common denominator? Nope. X minus 5 and x plus 5 are different, right? So that means I need the LCD. What is your LCD? Yep. X minus 5, x plus 5. That's almost so easy it was hard. And that is my LCD. Is that part okay? So I'm going to write everything over the common denominator. X minus 5, x plus 5. What's the first fraction missing? X plus 5. So if I multiply in x plus 5 to the bottom, I got to multiply it into the top. So that's going to be 6x times x plus 5. Carry down the minus. What's your second fraction missing? It's missing x minus 5. If I multiply the bottom, I've got to multiply the top. So that's going to be 1 times x minus 5. Are you guys with me on that? Is that part okay? Do you think if I didn't write the parts in blue, you could have gotten here? Hopefully, because I'm going to start doing that. All right, so what do I do here? Well, the good news is the denominator is in a nice factored form. Leave it alone. The numerator, however, we're going to have to work out. So let's distribute. That means I'm going to wind up with 6x squared plus 30x minus x plus 5 over the LCD. X minus 5x plus 5. Combine like terms. So that's going to be 6x squared plus 29x plus 5 over the LCD. X minus 5x plus 5. You guys with me so far? So we've performed the subtraction. The only thing left is to see if this is going to simplify. To see if this simplifies, we need to factor. Now, in this section, it's going to happen more than before. A lot of these quadratics are going to turn out prime, but they don't always, so we got to check it out, right? So let's see what we can do with that numerator. What do you got? 6x and x. 1 and 5. The only way that's going to work is a positive 30x and a negative 1x for the outside and inside respectively, right? But that doesn't check out, right? Because negative 1 and positive 5 is negative 5. That didn't work. Got something else? 2x and 3x with 5 and 1? I mean, 15 and 2, that's not going to get you there either, right? And if you flip it around, that's going to be 10 and 3, which doesn't get you there either. So that's it. It might take you a little longer to work through the options, but that's okay, right? I'm just more practiced. This is our final answer. Now, if you guys want to get lazy, do not just stop writing the denominator. Right? If nothing else, just write at least LCD to remind yourself that it's there. Because the easiest thing to do is forget you had a denominator and then not have one in your answer, which makes it wrong. Right? It's like your kid. If you're in the mall, you do not let go of your kid's hand. Right? Else an axe murderer kills the kid and it's all your fault. So there you go. All right. Let's say we want to do 9x plus 2 over 3x squared minus 2x minus 8 plus 7 over 3x squared plus x minus 4. So I just want to add these two rationals. Do I have a common denominator? No, and that means
You have to find one.
I have to find the LCD. So I need to factor my denominators to see what I'm working with. In both cases, the GCF is 1 and there are trinomials that are not perfect square trinomials, and that means
Trial and error.
trial and error. Hopefully by this point you're doing a lot less erring. So we got 3x and x, and 8's got some choices. What do you want to try? Try something. If I try 2 and 4, that's going to give me 12x and 2x. 4 and 2, that's going to give me 6x and 4x. Ah, a negative 6x and a positive 4x works. Do you guys agree? That's how it works. All right, 3x and x. This one's pretty easy. Maybe.
4 and 1.
4 and 1, okay. If my inner term is positive 4x and my outer term is negative 3x, it works, right? Trial and error. You just get good at it by trying and erring and trying again. So what is our LCD here? You're just going to wait until I write it down, right?
3x plus 4.
Yeah, 3x plus 4.
X minus 2x minus 1.
X minus 2x minus 1. Is everybody okay with that? Right? That's what we need to take care of these denominators. So we're going to put everything over the LCD. And again, if you want to be lazy, at least just write LCD as a placeholder. Meanwhile, what was the first one missing?
X minus 1.
So we've got the x minus 1 times the 9x plus 2, plus, what was the second one missing?
X plus 2.
It's x minus 2, right?
Oh, yeah.
Okay. Let's make sure I don't have a mistake. You guys okay with that? So the denominator is in a nicely factored form. We're not going to mess with it, but we are going to multiply out the numerator. That's a 9x squared. That's a negative 9x and 2x, so minus 7x minus 2, plus 7x minus 14 over the LCD. Is that okay? FOIL out, distribute, multiply it all out, and then combine like terms. 9x squared minus 16. Oh, that worked out nicely. Maybe I planned it that way. Or maybe your book did and I just picked it.
Quick question. Why didn't you do the 3x plus 4 along with the rest of them?
They both had the 3x plus 4, so nobody else needed an extra one. Only what was missing.
Where'd you get the 7x from? Oh, never mind. Never mind. I see it now.
Okay? All good questions. And then this is still over the LCD.
Why is that one negative though?
Now, it just so happens, we can factor that. That is a difference of squares. 3x plus 4, 3x minus 4. And my LCD was 3x plus 4, x minus 2, x minus 1. So here's my fully factored out answer, right? Does it simplify?
Yeah.
3x plus 4 over 3x plus 4 cancels, and we're left with 3x minus 4 over x minus 2, x minus 1. Here's my simplified answer. It's rare, but it does happen, so make sure you check for simplifying for these. Let's try a tougher one. What if I give you 2 over x minus 6 over x minus 5 minus x minus 35 over x squared minus 5x. Ah, so we have 3 terms now. Do they have a common denominator? Wah, wah. So that means we have to find one. And that means seeing what we're working with, right? So factor all of your denominators. Well, luckily x is x. X minus 5 is x minus 5. What about x squared minus 5x? GCF of x, leaving behind x minus 5. You guys agree? So your LCD is what? X minus 5. Are you guys all on board with that? Is that okay?
Yeah.
So everything over LCD, right? What was missing from the first one?
X minus 5.
So you have a 2 times x minus 5. What was missing from the second one? So minus 6 times x. What was missing from the third one? Nothing. So it's just minus x minus 35. Of course, note that negative applied to the whole fraction, therefore the negative applies to that whole numerator still. So parentheses. Are you guys on board? So if we multiply out 2x minus 10 minus 6x minus x plus 35 over the LCD. You guys agree? Combine like terms, what do you get? Negative 5x plus 25 over the LCD. You guys with me? Did I just make this up?
No, we didn't.
Can I factor? What can I factor?
5.
GCF is 5. Should I exercise my option to factor out the negative? I mean, I asked, so that's a trick question.
Yes.
Your leading term is negative, so factor out negative 5, leaving you with
X plus 4.
x minus 5. Don't be afraid to just do a quick redistribution to check and make sure your answer works. And your LCD was x over x minus 5. Does this simplify? X minus 5 divided by x minus 5 is 1. We have a common factor, so we're left with negative 5 over x. That was the nicest answer with 3 terms.